Hi all, welcome you all to this new video today. So this lecture series is about fluid power systems and industrial automation. This is Michael Jones, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology. This lecture series we are going to see about fluid power systems for the course 23 MCB 302, Fluid Power Systems and Industrial Automation. And in this, the first unit is discussing about the fluid power principles and hydraulic pumps. So to brief about the topic, fluid power principles is that all the guidelines, what are the basic terminologies that is going to be guiding fluid power systems, and the hydraulic pumps is the displacement and non-displacement pumps. So we are going to discuss gear pumps, vane pumps, loan pumps, all these different types of pumps and their applications will be discussed in this unit. So welcome you all to this new video. First, to start up with, I'm just giving you some examples and certain guidelines. You can see these are just day-to-day applications what we are experiencing in our real life. We can see all these parameters in our day-to-day life. So the first image is a JCB and earth mover. The second one is a tree cutter. The third is an hydraulic lift jack. Then the fourth is a wheelchair, a pneumatic operated wheelchair. Then we are having a vacuum suction in a cookie manufacturing place. And the last image is a robotic arm that is going to perform certain welding operations. So these are different areas, different varieties of areas where we are going to use fluid power. Okay, so fluids are going to be employed, fluids are going to be used in these applications to do some work. That is the major idea behind fluid power systems. So what are the definitions we are going to see? What is a fluid power? When a fluid is used to transmit power from one location to another, then it is a fluid power. Fluid power is just another source of power that is going to do some work. It is going to transfer energy. It is going to transfer some material from one place to other. As like electric source or heat energy, whatever it is, the fluid is going to be used. What is a fluid? We know the states of matter of a particle is solid state, liquid state and gaseous state. So solid, liquid and gas. In this leaving solid, all the matter that is going to be in a liquid form and a gaseous form is termed as fluid power. So fluid power, in under fluid we are having two categories. What is it is that hydraulics and pneumatics. So hydraulics is that when we are going to use a liquid. Okay, so we know in the states of matter we are going to see liquid matter. All the liquid matters are termed as hydraulics, and the gaseous matter is to be termed as pneumatics. Okay, so liquid form, liquids are flowing under pressure to transmit power from one location to another, and pneumatics we are going to use gas flowing under a constant or a variable pressure to transmit power. Okay, now the basic formulas, the basic mathematical expressions that are going to guide these principles is the relationship between the force, pressure and area. So all these terminologies we been already saw in physics, the basic physics. So force is equal to pressure into area, and we are going to rearrange that as pressure is equal to force by area and area is equal to force by pressure. So these are the terminologies, and that is going to define or guide the pressure. We saw in the previous slide, we saw the liquids in under pressure and gases under pressure. So that is going to be the biggest term. So this concept was developed by Blaise Pascal in the 1640s, and the SI unit for pressure is Pascal. So from the name of the inventor we have coined the name Pascal. Okay, so the mathematical expression is given here. 1 Pascal is equal to 1 Newton per meter square. 1 Pascal is equal to 1 Newton per meter square. Right. So what is Pascal's law? So Pascal derived a law, and that law is going to be confined, and it is going to be used in a all the fluid power systems. So this is the law that is going to be guiding. Okay, so what is Pascal's law? We have seen here. I have given you a image on the right side. It is just a box container. It is a container. Inside the container there is a matter. Okay, that matter may be a liquid matter or a gaseous matter, and we are just having one hole or one way in the top, and pressure is going to be applied through that uh, opening. Okay, so that pressure is going to be applied in a confined fluid at rest, is transmitted undiminished in all directions. So you can see the arrow marks in the container. All the fluids, the powers will be transmitted equally in all areas and under right angles to them. So it will be perpendicular, it will be mutually perpendicular, and it will be transferred. So the Pascal, the basic thing is Pascal's law. So the Pascal's law, hydraulic press, we can see. So only a 10 pound is given on the left side, and the right side we are going to lift 100 pounds. So this is the, the application of a Pascal's law, hydraulic press. Okay, so for an application we are using hydraulic press. So 10 pound is being pressed in the bottom side, and 100 pound is lifted. Okay, you can see the difference in areas. So the area may be different, but the pressure applied is equal. So what are the advantages of a fluid power is given here? Multiplication and variation of force, easy and accurate to control. Power source controls many operations, high power to low weight ratio, and low speed torque, constant force and torque, and safe in the hazardous environments. So certain basic components and references. Thank you.